Here is a problem where we will use side-by-side box plots to compare results of a study. So we have two groups of women. We have the breastfeeding women and the women who are not breastfeeding, and what we're measuring is the percent change in the mineral content of the women's spines over 3 months. So if the change is negative, that would mean that the women lost mineral content. So negative means a loss of mineral content, and a positive would mean a gain of mineral content. So it's important to read the question carefully and try to really understand how the measurement is done and what exactly the numbers mean. So now the data, the raw data were given, and what we did was we constructed side-by-side box plots. And if you remember, this is how a box plot is constructed. So this is the max, and this is the minimum. The line in the middle is the median. This is the lower quartile, and that level is the upper quartile Q3. And same thing here, that line in the middle is the median, the lower quartile, the upper quartile. If we are given and this is the minimum and the maximum, of course. So if we were given the box plots, then we could kind of estimate the 5 number summaries by looking at these numbers on the y-axis. So this is your minimum, and that's your Q1, median, Q3, and then that's the max. So we're going to look at the two box plots and first write down the roughly the mean, the median, and the quartiles. Okay, so for the breastfeeding women, negative 5.5 and negative 2.5. So that's negative 5.5, negative 2.5, the lower and the upper quartiles, and the median is roughly here. So once you write down the 5 number summaries of the two box plots, we can kind of explain our rationale for our conclusion in a very concrete and a specific kind of way. But as soon as we look at the box plots, if you notice that the box plot A is set lower than box plot B, which is the box plot for the breastfeeding women. Okay, what does that mean? The numbers that define the median for the two sets, the medians, one is clearly much higher than the other. So the median here is roughly maybe a 0, and look at the median here. It's like a negative 4. Okay, so that means that the median bone loss is 4%, and for women who are not breastfeeding, the change was a 0%. That's the median. So what that means is the median 0% tells us that there was neither a loss of bone mineral nor a gain of bone mineral. So clearly the median for the breastfeeding women is much lower than the median for the non-breastfeeding women. So that's one indicator. Now the other thing we could compare are the quartiles. So between the two quartiles, the middle 50% lies between the two quartiles. And why is that? So if you have this data set, the median divides the data set into 2 equal parts, and the quartiles further divide the 2 halves into equal parts, and these three numbers together divide the entire data set into 4 equal parts, which means the bottom 25% is anywhere between the minimum and the Q1. The top 25% is between the Q3 and the maximum. And the middle 50% of the data lies between Q1 and Q3. So the middle 50% of the numbers or the data lies between negative 5.5% and Q3, which is negative 2.5%. And in the case of non-breastfeeding women, the middle 50% lies between negative 2.25% and plus 1%. Compare these numbers. For the respective numbers, if you compare the Q1s, the lower quartiles, clearly the lower quartile of the non-breastfeeding women is higher than the lower quartile of the breastfeeding women. Again, same thing, the upper quartile of the non-breastfeeding women is much greater than the lower quartile of, or the upper quartile of the, so these are the upper quartiles, Q3s. So we're comparing upper quartiles. So the upper quartile of the non-breastfeeding women is much higher than the upper quartile of the non-breastfeeding women. So that could be another reason. So these are different ways in which you can explain why one group, in conclusion, the one group, that is the non-breastfeeding women, the non-lactating, non-breastfeeding women, lost less bone mineral content than the breastfeeding women. And it could be any one or two or three of these reasons. You could give your rationale based on quartiles, the middle 50%, comparing the medians, and overall looking at the box plots and how they are set in comparison to each other. So the box plot for breastfeeding women is set lower. What does that mean? It means that the ranges of values for women who are breastfeeding is much lower than the ranges of values of bone mineral change in bone mineral content for the non-breastfeeding, non-lactating women. So any of these three reasons could be used to justify that overall the non-breastfeeding women lost less bone mineral content than the breastfeeding women.